Good morning all. This is Dwarkanath SK, Assistant Professor, Department of EEE, SJBIT, Bangalore. So welcome to today's session on insulator problems in transmission and distribution. This is for 5th semester students with the 21 scheme. The subject code is 21EE51. So let's move on to the problems associated with the insulator based. So let us take the first problem. The given question is, each line of a three-phase system this is suspended by a string of three similar insulators. If the voltage across the line unit is around 20 kV, calculate the line to neutral voltage and urged metal work of a tower to be 1/10th of the capacitance of the insulator. So if you see the right side here, you can see the arrangements over here. The shunt capacitance is placed over here and the mutual capacitance are placed over here. They are represented by C and this as C1, C2, C3. Current, incoming current and outgoing current. So at point P node, I2 is the incoming current and capital I1 and small I1 are the outgoing currents. On the same lines point Q and point R. And V1 is the voltage drop across the first insulator, V2 is the voltage drop across the second insulator, and V3 is the voltage drop across the third insulator. V is the total voltage drop if we take into the all three insulators into consideration. Now applying KCL at the node at this particular junction point P. So incoming current is I2, which is equal to a small I1 plus capital I1. And we all know that C1 is equal to K times of C, which is 0.1 into C. So 1/10 they have given the K value, it is 0.1. And V2 is equal to 2 pi fc omega. So what is V1, which is 2 pi fc1 plus 2 pi fcv1. So this will be equal to V2 is equal to V1 times C1 divided by C1 plus 1. So or in terms we can generally write it as V2 is equal to 1 plus K times of V1. Now applying KCL to the node at Q, what is I3? I3 is equal to I2 plus I2. If you see at this node, the incoming current is I3 and two outgoing currents are small I2 and capital I2. So applying current in terms of omega and the voltage, so 2 pi fc V3 is equal to small I2 is 2 pi fc V1 plus V2 plus I2 is equal to 2 pi fc V2. On simplification, so we get V3 is equal to V1 times K square plus 3K plus 1. So here V3 is the voltage drop across the line unit which is closest to the line conductor. That is the conductor line. And in this given problem it is given as 20 kV. So substituting the value over here, V3 is equal to 20K, 20 into 10 power 3, which is equal to V1 times K, the value is known, it is 1/10 or 0.1 square plus 3 times of K plus 1. On solving, we get the value of V1 is equal to 15.2671 kV. So in the earlier equation, what is V2? V2 is equal to 1 plus K times of V1. V1 value is also known, K value is also known. On substituting, we get V2 is equal to 16.7938 kV. So total voltage drop, that is line to neutral, phase voltage is given by V is equal to V1 plus V2 plus V3. So V3 is the voltage drop near to the line unit, V2 is just now we have found it, and also V1. Adding V1 plus V2 plus V3, that is V1 is equal to 15.2671 plus 16.7938 plus 20. So total voltage drop is 52.0609 kV. So once if you find out the total voltage drop, it is easy to find out the string efficiency. So we all know that string efficiency is given by the formula voltage across the string divided by n times the voltage across the line unit. So here voltage across the string is the total voltage, or just now we found it is 52.0609 divided by n. Here represents the number of insulators in the unit, which is equal to 3, and voltage across the line unit is 20. On simplification, we get the string efficiency as 86.768%. Okay, so hope you guys have understood the concepts of finding out the insulator related voltage drop problem in a transmission line. So any doubts, any queries, you can contact me. Thank you, one and all.